All right, so for this problem, rewrite in vertex form. So I like to move the constant over first. So next would be to factor out the a value, but it's already 1, so I don't need to do that. So next I would need to figure out what value to fill in the blanks with. So maybe I'll just do it in one step to save space. Okay, so down below, the next line I know would be x something squared, right? The goal is to make a perfect square binomial. So this constant is always half of the previous b value. So plus 16 divided by 2 becomes plus 8. Okay, so this plus 8 must have gotten squared. So 8 times itself is plus 64. Okay, so if I add 64 to the right side, I need to an equal action to the left side. So in this case, the 64 is not affected by anything. There's no coefficient in front, which multiplies this in parentheses. So it's also a plus 64 on the left. Okay, so the left side simplifies to a of x, and then minus 71 plus 64 is minus 7. Okay, and lastly, I would add 7 to both sides. Okay, so that leaves me with a of x equals quantity x plus 8 squared, and then plus 7. Okay, so the vertex itself, it's not directly asked for, but the vertex is h, so this is x minus negative 8. So negative 8 comma positive 7. And that allows me to easily write the sequence of transformations. Because I know the parent function, x squared, has its vertex at 0, 0. Right, so if I look at how the vertex got shifted from the parent to this one, the vertex moved 8 units to the left and 7 units up. Okay, I'll do problem 3 also. So again, first I would subtract this value from both sides. Okay, so this time my a value is not 1, it's 2, so I need to factor that 2 out. Oops, sorry. So the 36x with the 2 factored out is now 36 divided by 2 is 18x. Okay, and now I got to figure out the next part, the perfect square binomial. So you always keep the factored out coefficient. And then this part always looks like that. And then this constant is always half of the previous b value. So half of positive 18 is positive 9. Okay, and then this positive 9 got squared. So 9 squared means the previous c value must have been 81. Okay, so I added 81 in the parentheses on the right side, but this 81 is affected by the coefficient of 2. So 81 times 2 means I really added a total of 162. So I got to add 162 to this side also. Okay, so that brings me to b of x minus 8 equals 2 times the quantity x plus 9 squared. And lastly, add 8 to both sides. Okay, so there's the vertex form. So the vertex itself. So again, x minus h, so x minus negative 9, and then plus k. Okay, so in this case, our a value is not 1, so that means we have a vertical stretch by that a value. So first, we can do the vertical stretch, and next we can account for the translations. So again, from 0, 0, we must have gone 9 units left and 8 units up. Okay, jumping ahead a little bit. So maybe g of x. So this one starts in factored form, so we would want to distribute it out first. Okay, so from there you can complete the square. This one will have fractions, but that doesn't mean there's anything wrong. So problem 7, I want to do one with a negative a value. So okay, so in this case the a value is negative 6, so I need to factor that out. Negative 6x squared with the negative 6 taken out is now just x squared, and negative 12x divided by negative 6 is plus 2x. Okay, so looking ahead, I know that the perfect square binomial will take this format. Half of 2x, or half of the b value of positive 2 is positive 1. Okay, maybe I should do the other color. Plus. Okay, half of positive 2 is positive 1. Then this positive 1 gets squared. 1 times 1 is plus 1 up here. All right, but this plus 1 that I squeezed into the parentheses gets affected by the negative 6 in front. So 1 times negative 6 means I actually subtracted 6 from the right side. So I also need to subtract 6 from the left side. Again, 1 times negative 6 is why I put a negative 6 over here. So 13 minus 6 is 7. And then lastly, subtract 7 from both sides. Okay, so there is our vertex form. The vertex itself would be at -1, -7. Okay, and then the sequence of transformations. So again, we can deal with the a value first. A is -6. So because it's a negative value, that means we need to reflect over the x-axis. Next, because the absolute value of a is 6, that's a vertical stretch. And then finally, the vertex itself got translated from 0, 0. We went 1 unit left, 7 units down. Okay, so jumping ahead to problem 10. So here we're sort of combining transformations. So they want us to take m of x and translate it 1 right, 6 down. So first of all, let's get m of x in vertex form. So that would be x minus 1 squared. So -1 squared means we have to add 1. Oops, sorry, the -4 plus 1 is now -3. Okay, and then lastly add 3 to both sides. Okay, so there is the vertex form, which allows us to see that the vertex of m of x is at 1, 3. Okay, but another way we can think about it is, remember that vertex form is a times the quantity x minus h squared plus k. So when we say x minus, well, let me just write it over here. Okay, so comparing it to the standard form, we see the a value is this invisible 1 in front. The h value, x minus h, so x minus 1 means h is positive 1. and k, the value added at the end, plus k plus 3, k is 3. Okay, so what we want to do is we want to translate 1 right and 6 down. So we remember from absolute value functions that the h value controls left or right. So if you're going further right, you are adding to the h value. So the h value originally was 1. So to make it go 1 right, you add another 1. Okay, and then now to translate 6 units down, downward is controlled by the k value. So the k value used to be 3, but now we subtract 6 from it. Okay, so the a value is unaffected. There was no vertical stretch or reflection. So a is still 1, but the h value used to be 1, but then we added 1 more, so the h value is now 2. And the k value used to be positive 3, but we subtracted 6, so the new k value is negative 3. Okay, so now we substitute these values back into our vertex form. So a is still 1, so I don't need to write that. X minus h becomes x minus 2 squared, and then plus k becomes plus negative 3 or minus 3. Okay, so there would be your answer to part A. Let's see. Looks like we have a typo here. It's missing m of x is vertically stretched by a factor of 2. Okay, so again, back to the original m of x, not based over here. The original m of x had a equals 1, h equals 1, k equals 3. So when you vertically stretch, that affects the a value. So vertically stretched by a factor of 2 means you multiply the a value by 2. So there's no translation, so h is unaffected, k is unaffected. All right, so converting it back to vertex form then, we have a becomes 2, x minus h is x minus 1 squared, and then plus k becomes plus 3. Oh, wait, sorry. So if we think about this, the original vertex was at 1, 3. So when you vertically stretch it, the k value will also get affected. So actually, right, because if you were to grab it and stretch it vertically, the y value will become twice as far away. So it's actually not only the a value, it's the k value that gets affected. Okay, and so over here, k of x translated 5 units left. So k of x, I'll just copy down. Okay, so let's identify the a, h, and k values. A is this invisible 1 in front. H, so x minus h turns into x plus 3. So h must be negative 3. Because subtracting negative 3 is like adding 3. And finally, the k value is negative 6. All right, so I want to translate this 5 units to the left. So left and right translation is controlled by the h value. So to the left is negative. So from the current negative 3, I now need to subtract 5. Okay, so nothing else is affected. A stays the same, k stays the same. It's only h that gets affected. Negative 3 minus 5 is negative 8. Okay, so putting that all into vertex form, we've got a is still 1. X minus h becomes x minus negative 8. So x minus negative 8 is x plus 8. squared, and then plus k is minus 6.